Morning students. The last class we had discussed about that factors affecting the atomic radius, that is atomic size and electronic configuration, removal of electrons from different orbitals, and the shielding effect. Now we are going to talk about electron affinity. You see, the electron affinity means electron affinity is nothing but gaining entropy. Gaining enthalpy. You see, this is quite commonly electrons, correct? No, electrons gaining enthalpy. You see, electron affinity, it every time it will be the negative charge only, negative charge. Okay, first we are going to talk about what is electron affinity. Definition. We are going to talk about definition. Definition is the amount of energy released when an electron is added to an isolated gaseous neutral atom. You see, electron affinity is nothing but the amount of energy released when an electron is added to an isolated gases. You see, the last class I told that if electrons, you see, the electrons if absorbs, see, this is the atoms, if we are passing the amount of energy to the orbital, if it have two, one is positive sign, one is negative sign. See, when will the positive, the enthalpy means energy is being absorbed. Negative will be released. Energy will be released. It is endothermic. It is exothermic. Okay, you see, for that only I told that electron affinity is negative charges because it will be released. Okay, we take example like we'll take example. You take any atom having a gaseous atom, if the electrons is added to the atom, correct? Now quite commonly it shows negative charges, gaining of electrons, and you can given the electron, also atom, we take example like another example, that is chlorine. It is in neutral state having a gaseous form. If you add electron to that, it become chlorine in gaseous state. See, this is while chlorine neutral to chlorine anion, its energy enthalpy change is equals to minus 348 kilojoules per mole. We want to talk about the units to measure the electron affinity is electron volt per atom, or we can also call as kilojoules per mole. Okay, you see, ionization energy will be positive. Positive charges when come to, because it will be absorb the energy. When come to electron affinity will be negative because it energy released. Okay, we take another simple example to explain you. Okay, you see, example, I'm taking that oxygen in the gaseous state. If we add electrons, it become oxygen anion. Okay, its energy affinity is a negative sign, correct? No, because it is first electron affinity. First electron affinity, for that we'll write 1. Similarly, if you remove from anion gaseous state, if you remove the electrons, okay, it releases. See, if we added the electrons to the primary oxygen anion, in that we add a 2 minus gaseous state, it will be electron affinity 2, correct? No, it will be positive. Why it will positive? See, negative will be positive, correct? No, negative will be positive. You see, I am telling that first neutral state, in neutral oxygen, if we add a electron, it become anion. Okay, it is first electron affinity, it must be a negative. When come to here, in anion, first electron affinity anion oxygen, if we add electron to that, you see, electron charges is negative will be positive. For that I am telling electron affinity will be positive in secondary electron affinity. Okay, you see, electron affinity, it is a non-metal property. First of all, electron affinity it is non-metallic property, because non-metals, they are tendency to gain the electrons. You see, non-metals, why they can ask you electron affinity is a non-metal property. Why? Because non-metal they have tendency to gain electron in a periodical table. Okay, you see, in periodical table, halogens are very important point. Halogens, they have high electron affinity. They can ask why halogens in periodical table, halogens having the high electron affinity, because the halogens, you see, halogens, if you write the halogens electronic configuration, ns2 np5, it need only one electron, it ready to take the electron from the energy, then it becomes the completely ns2 np6, correct? No, for that it have the high electron affinity, means it ready to it have the tendency to gain the electron from the periodical table. Okay, for that halogens are highly electron affinity. Next we are when come to noble gases, you see, after completing noble gases, they have, you see, noble gas or inert gas, you can take anything. Noble gas have zero electron affinity. Noble gas have zero electron affinity. Why it has zero electron? Because it is completely filled orbitals. It does not want any electrons to completely filled. Okay, for that it does not show any electron affinity. You see in periodical table, if gaining of the electrons occur, then it is electron affinity. If losing of the electron it occurs, it is ionization energy. Okay, next we are going to talk about variation of electron affinity. In what variations are occurred in periodical tables. Okay, you see the variations of electron affinity in periodical table. If you talk that periodical table in two simple way, that is groups and period. What happens in groups? First we are going to talk about groups, correct? No, groups, the electron affinity means top to bottom electron affinity will be decreases. You see, it will be decreases. If decreases, it quite commonly increases. I will just sign. Then what will I want to write? In electron affinity decreases when top to bottom. Why decreases? Because atomic size increases. Atomic size increases, then nuclear charges will be decreases, correct? No, what is nuclear charges? The distance between the nucleus and the valency of electrons. Quite common, atomic size increases means then nuclear charges will be decreases. Nuclear charge decreases. The force means the force of attraction between the nucleus and the electrons, it will be decreases. See, if you write the atomic size increases, then the attraction between the valency electron loss, nucleus to valency electrons will be distance is more, then nuclear attraction between these two nucleus and electrons will be less. For that I told that nuclear charge will be decreases. In the case of halogens, belongs to the group 17. You see, in the case of halogens belongs to group 17. You see, if you write the groups like fluorine, chlorine, bromine, iodine. Okay, see, fluorine, well, what I talked, if atomic size top to bottom it goes, it will be size increases, electron affinity decreases. Well, come to in the case of chlorine and bromine, I am talking about in the case of chlorine and bromine. Chlorine in some in the cases like chlorine is greater than F. Electron affinity of chlorine is greater than F. Okay, chlorine greater than F. Why it has more? We talk that F is F in the second shell, no? Chlorine is third shell. Then the F atomic size, I will write atomic size small, then its electronic configuration 1s2, 2s2, 2p5, correct? No, 2p5. In the p orbital, electrons is added. See, already I told that if electrons is added to this group, F, what happens? Electron is added. That time the electron in the p orbital, sp, okay, sp, electrons will be already in the p orbital. If the electrons is added to this what happens? Electron repulsions are occurring. Electron repulsions are occurring. Why it occurs? Because negative charges, like charges will repel, unlike charges will be attract. Similarly, you will tell to chlorine. See, if you talk about chlorine, is quite commonly atomic size big, correct? No, because the third shell will comes P only, it becomes third shell. We'll write 1s2, 2s2, 2p6, 3s2, 3p5. Here you see repulsion occurring. These repulsions we call in the F, the electron repulsions are occur. It is more repulsions are occurring in p orbital, and it we call as inter electron repulsions. We call what we call inter electron repulsions, or inter repulsions of electrons. You can write inter electron repulsions. When come to chlorine, here also you can ask, sir, here also repulsions are occurring. No, because it in P it is only one electrons. In P it having the electrons repulsions are occurring. But the atomic size compared to F, it is big. Correct? No, atomic size is bigger then what will shows? It shows less, it shows the repulsion, but it shows less inter electron repulsions. It shows electron repulsions quite commonly, but less inter electron repulsion. Okay, for that we will tell that in the case of halogens belongs to group 17, chlorine is greater than fluorine. Okay, for that only I told that in the periods for atomic size increases, electron affinity will be decreases. Okay, next we are going to talk about period. If we talk about period, electron affinity will be increases quite commonly. Why it increases? Because atomic size will be less. Atomic size will be less, and nuclear charges will be more. Nuclear charge will be increases. Okay, this is about the variations of electron affinity in groups and periods. Next we are going to talk about factors affecting the electron affinity. Factors affecting electron affinity. First point, atomic size quite commonly, atomic size. Second, nuclear charges, nuclear charge. Third, electronic configuration, How can you tell that electronic configuration will affect the electron affinity? The atoms which has completely filled configurations and off filled configurations, they have electron affinity will be 0. Okay, off filled. For example, you take in p orbital, if it fills off, or noble gases, you take completely filled off, it is off filled, it is completely filled. Okay, the atoms which have the off filled and completely filled, they have electron affinity will be 0. Okay, why? Because it will be 0, because extra stability, and they have less tendency to accept the additions, because extra stability, and they have less tendency to accept or to gain, okay, you write anything, accept or to gain addition electrons. These three factors will affect the electron affinity. Next we are going to talk about electron negativity. Electron negativity. You see, the electron negativity in 1931, Louis Pauling, 1931, Linz Pauling. Electron negativity was introduced by the 1931, the Linz Pauling. He given the definition that the ability of an atom to to share pair of electrons towards itself. Okay, see, for example, we'll take that, I'll write the definition lastly. You see, if we take x and y, for example, x and y, we take an example, there are two persons, we are given the tug off between them, it is center. You see, the x is weaker compared to y, y is stronger. Then what happens, this tug off, what the tag was pulled towards the y side, You see, we can give the another example, like HCl. You see, if you're going to write the configuration, 1s1 chlorine, we'll write that chlorine 1s2, 2s2, 2p6, 3s2, 3p5. See, it ready to gain the electron from the H. It become negative, correct? No, it ready to pull the electron from the H, it become negative. Then loss of electrons, it become positive. Do you understanding here? We have taken, it's ready to pull the one electron from the hydrogen. For that, it gaining of electrons, we put a negative sign. When come to H, it giving the electron, for that it become plus. Okay, now we write the definition. The ability of an atom to attract shared pair, it become pair, no, it became pair, shared pair of electron towards itself. Okay, next we are going to write the difference between electron affinity and electron negativity. Electron affinity, electron negativity. Okay, while electron affinity, it accept the electrons, means the electron negativity is accepting, correct? No, electrons accept electrons, but it attract electrons. Then it is isolated atoms, it is bonded between both, it will be bonded, no, it will be taken as bonded atom. It has electron affinity. Already told that units, that is what I told, kilojoules per mole or electron volts per atom, correct? No, it's have measured quantity units. We'll take that measured quantity units, that is electron volts per atom or kilojoules per mole. Okay, when come to here electronegativity, there is no units. Now we're going to talk about variations of electronegativity. Variation of electronegativity. If we talk in periodical table variations, we will write that period and group. Group electronegativity will be decreases. Group, it will be decreases, here increases. Group electronegativity will be decreases because atomic size increases. Nuclear charge quite commonly will be decreases. When come to period electronegativity will be increases, atomic size decreases, nuclear charge will be increases. Okay, next we are going to talk about factors affecting the electronegativity. Already I told that factors, it is atomic size quite commonly, and charges, nuclear charges. Okay, yeah. Next we are going to talk about factors affecting the nuclear factors affecting the electronegativity. Factors affecting electronegativity. First factor, size of the atom, correct, or atomic size of the atom. Quite commonly in electronegativity we'll talk that En, electronegativity for taking, is inversely proportional to the size of the atom size. You see, if you take a small atom is having atomic size, then electron affinity, electronegativity is more compared to large atom. Okay. Next, I talk on about nuclear charges. Nuclear charges will be, I told that the distance between nucleus and valency electrons, in nucleus having positive and the electron will be negative, we call that cation and anion. Okay. Charge on cation is nothing but electronegativity is directly proportional to positive charge. How it is directly proportional? You see, the cations is more electronegativity than the parent atom, right? Cation is more electronegativity than parent atom or neutral atom. Okay, you can take example Fe3 plus is greater than Fe2 plus, or Mn7 plus manganese is greater than Mn2 plus. Okay, next I am talking about third point, charge on anion. M more, what will write here? Less. Okay, electronegativity is inversely proportional to negative charge. For example, O minus is greater than O2 minus, because you see here more electronegativity compared to here, because here electron repulsion are occurring. Yeah, more electronegativity. Okay, next fourth point, hybridization. If you talk in sp2, sp3, here the s having 50% orbital and 50% of p orbital. When come to here sp2 hybridization, here 35 or 33% p will be more. When come to sp3, here 25%. Next we are going to talk about applications. Next we are going to talk about applications of electronegativity. You see, the first application, that is a name compound. First application is nothing but naming of the compound or name compounds. You see, you take any element with a more electronegativity, the suffix will be id in last. Okay, we take example like HCl and SF6. Okay, see, HCl is nothing but hydrogen chloride, correct? No, hydrogen chloride. You see, id will be the suffix, to the electronegativity, having more electronegativity. When SF6 is sulfur hexafluoride, you see, id is a suffix. Then we will write that the element with more electronegativity, the suffix IDE. See, IDE is written at the end. It's the first for violating the naming of the compound. Okay, second point, we can find the percentage of ionic characters in covalent bond. Okay, we can find the percentage of ionic character in covalent bond. We take HCl. It has the covalent bond, sharing of the electrons between non-metal atoms. Okay, you see the sharing of electrons. The previous one I explained that the electrons are sharing, correct? No, electrons are sharing. Then it is a covalent bond, sharing of electron between non-metal atoms. You can take another example, NaCl, sodium chloride. it has ionic bond, transferring of electron from metal atom to non-metal. You see, it is a metal plus it is non-metal. The electrons are transferring from metal to non-metal, metal to non-metals. What you are having? Ionic bond, transfer of electrons. Here covalent bond, sharing of electrons between non-metal atom. Okay, they given the formula to find the ionic characters in covalent bond, that is 16 del X plus 35 del X whole square. What is del X? Is nothing but electronegativity. See, del X is nothing but electronegativity. Difference means it is delta is nothing but difference between two elements. For example, see, we take H and F. See, it's have the difference. Okay, like H having electronegativity 2.1, fluorine having the 4. If delta X, the electronegativity is 1.9. If you take delta X is equals to 1.9, then if you add it to this formula, 16 into 1.9 plus 3.5 into 1.9 whole square will get 43%. By using this formula, we can find the ionic characters in the covalent bond. Okay.